Alrighty, welcome. So today we're going to be looking at creating some predictions. And in particular, we're going to be looking at what's called the least squares line of best fit. And we're going to be doing it in Excel. Now, just to begin with, you can kind of see here that we've got a bit of data. In fact, it's got population and time, and as we can see, as the time goes forward, the population is going down. But you notice it's not going straight down. When we're looking at linear equations, we know that for a linear equation, it would look like a straight line. And as you can see here, we don't have a straight line, we have a bunch of straight lines, making up the line graph. But that's really complicated, and in order to work with a bunch of line segments, it's actually really annoying. You'd have to use some kind of piecewise graph, and it's a whole pain. So what if instead we just tried to approximate the line of best fit? So it's not going to be a perfect line, but you can kind of see that that line there that I just drew there, let's try again, right? That kind of represents the data, sort of. It gets pretty close to most of the points, but is it the best line? And that's what we're going to be looking for. What the least squares line of best fit is that it's not just a line that represents the data, it is the best line. So it is as close to all of the points as possible. And that's what we're going to be looking at having a play with today. So let's have a look at this data here. We've got time after sale, 0, 1, 2, 3. Oh, that is in years. And we've got the cars value. So it's 8,000, then 7,800, then 7,500, and 7,400. You can kind of go, some people kind of look at it and they start going, oh, looking for a pattern. It's like, oh, it's take 200, and then it's take 300, and then you go, oh, maybe take 400, and then it's take 100, and you go, okay, there is no pattern. This is just real, random, raw data. And so we want to kind of be able to get an equation that's going to model this sort of data. So step one, put it in Excel. So I've just jumped into a blank workbook and I'm just going to type in my table. So all I've done is now I've just set up my table in Excel as well. And you can see I can select the whole table and we can create a line graph just by selecting the data, going up to insert, finding the chart button, and you'd be tempted to go with a line graph. If you choose line graph, you'll see you get two different lines. We actually want a combined line. So in order to get that, we have to go into XY or the scatter plots. And remember, we're looking for ones where the points are clearly marked and with straight lines connecting, which isn't the top one because the points are all separate. It isn't the next two because both of them involve curved lines, which is not what we want, but it could be either of the bottom two. I prefer the one that's got the dots on it, not just the points. So I'm going to choose that one here. And you can see now I've got my line graph. And you can see my axes are set up pretty well. There's a few more changes I need to make. The first one being that I want my axes titles, so primary vertical and primary horizontal. And now I'm just going to fix up those and pop a bit more information in. So you can now see this sort of picture that we're getting. And you can kind of imagine what it would look like to put a line straight sort of through it. You know, would it kind of go through like that? Where exactly would it go? And what we can now do is ask, hey, Excel, could you put in the best line that you could think of? So how can we do that? Well, if you click on elements and we click on trend line, we go, what sort of trend line do we want? Well, we want a linear one. Right? Basically, we want to model it with a straight line. And that's going to be helpful because we're pretty familiar with the old y equals mx plus c. We are familiar with that, so let's click on linear. And you can see it draws a straight line. Now it looks pretty good. Like it's not going through all the points, but the points aren't in a straight line. So there's going to have to be some compromise. And this is to be the best compromise. So what can we say about it? Well, we can kind of see that the line has what we'd call negative gradient. We can actually see that visually, that the line's going down. Now, on normal Excel, you can actually get up the equation of it pretty easily, but on mine, I just have to be a little bit cleverer. So I have to go into layout and find a layout where you can see there's an equation written on the thing. I can click on that, and now you can see that I get the equation of it. And so they think that the best equation for this data is, after some rounding, negative 210x plus 7,990. And they think that is the best line that models that data. Now, as we know, it's not going to go through these 4 points exactly, but you can kind of see that it's pretty close to the first point, and then, it gets relatively close to the others. And it kind of makes sense because, right, we saw that it went down 200, then down 300, and then down 100, and the gradient is down about 200. Not exactly, but it's pretty close. So this is how a line of best fit can be found. And what we can see is that we do have quite strong negative trend, which makes sense. Car value over time goes down. So as the more years go past, the value of the car continues to go down. So with a line of best fit, you can actually go through and predict future values and past values. So if I wanted to know how much the, car is worth in 10 years, well, I could set x is equal to 10, and I could predict and pretend and estimate how much we think the car would be worth, or even in 100 years or something like that. And all you have to do is substitute that number as your x value. Alternatively, if you wanted to know how long does it take until your say car is worth only $6,000, or maybe half price, so $4,000, you could just set y to say $4,000, and then rearrange and solve for x, and you'd be able to find out, well, how long is it? And just remember, you'll notice that we've used x and y. Why? Because time after sale in years is our explanatory variable, and our car value is our y value. And you can see even Excel knew that, but remember, Excel can be done, so sometimes it will make things up. Alrighty, I will see you in the next one. Goodbye.